This is for Year 12 Methods. It comes out of the 2017 VCAA Exam 2, question number 4H. So the lines L1 and L2 are the tangents to the origin of G of K, and this is my rule for G of K, and that's this brown curve. It's the family of curves. As K changes, it changes, and it's inverse. They both go through the origin 0, 0. So the lines L1 and L2 are the tangents to the curves at that particular point. So what we have then is we have L1, which is the tangent to one of them, and we have L2, which is the tangent to the other one, and I want the angle between them to be 30 degrees. Okay. If I could find the equation of the tangent to G of K and the tangent to G of inverse of K in the form of y equals mx plus c, I could work out the angle by taking the tangent of the gradients and then subtracting one from the other. Okay. So here is G. If I go calculation line, tan line at x equals 0, that gives me the rule, which is y equals kx 2kx plus nothing, of course. So therefore the gradient equals 2k. Therefore the angle is the inverse tan of 2k. And if I get the inverse, which is, and if I take it and I do the same thing, interactive calculation line, tan line at x equals 0, that gives me an equation which is y equals 1 on 2k x plus 0. So the gradient is 1 on 2k, therefore the angle alpha is going to be the inverse tan of 1 on 2k. So that gives me 30 degrees, or pi on 6, equals the inverse tan of 2k minus the inverse tan of 1 on 2k. Now, my knowledge of my table tells me that I've got a root 3 and a 1 on root 3, and one gives me the inverse tan of it gives me pi on 3, and the other gives me pi on 6, and the difference between them is pi on 6 and 30 degrees. So I'm thinking that this is going to equal root 3, and this is going to equal 1 on root 3. So I'm thinking that 2k is going to equal root 3, therefore k equals root 3 on 2. Let's check that with my calculator. If I have this and I go interactive advanced solve for x, it won't give me exact solutions. I'll ignore the negative. So this answer here, I'm thinking, is root 3 on 2. And it is. Okay, so k equals root 3 on 2.